So far we have used two different style of writing get level modeling. One is using the generate var, which is very compact in nature, but harder to debug. Another is simply uh, instantiating and keep on writing different instance names, repeated manner. That's a tedious job, but easier to debug. So by this time, actually, you know all the things you need to know for the get level modeling and get the project 3 done. From this lecture onwards, it will be more like your project 3 component description and what you need to accomplish by this lab and the other lab and this week and so on and so forth, so that you can actually meet your deadline. I won't be creating any milestones project and assignment like I have created for your lab 2, sorry, project 2. But these lab slides are your reference for what are the tasks you need to be accomplished by this week. Okay. So this is more or less your project 3 component list you need. We start with implementing barrel shifter. You can use it barrelshifter.v, or you can use any other file name, whatever convenient for you. But we ultimately need to do a 32-bit barrel shifter, which takes an input 32-bit and then 5-bit input of that, and then it output is a shifted value, and it takes a control signal which tells me whether it is a right shift or left shift. So this is my overall module description. And we already started a 4-bit barrel shifter here, right? Uh, Now extend that to the 32-bit barrel shifter. So what the changes are there? So 32-bit barrel shifter means I need to have like this multiplexer column selection of 5-bit of them, 0 to 4, right? And then that means I need to have also these 5 stages, 5 columns of multiplexer cascaded from in a cascaded form, and then we keep on shifting the connection from one column to the another. Like first column is 1-bit shifting by hardware connection of the wires. Second column is another bit of 2-bit of shifting. Third column would be 4-bit of shifting. Fourth column would be 8-bit of shifting, and fifth column would be 16-bit of shifting just by a hardware wire connection, right? This stage, see, the second phase is shifting 2 bits, means the my 0th bit is going to be connected to my uh, to my 1 to third position. It is being shifted 2 times. Okay, so extend its structure. So this will be, each column will have like 32 multiplexer, and there will be 5 such columns in your shifter. So this is one way shifting connection, and right shifter is right the other way, opposite way connection. uh, I would suggest you use the generate variable technique to do this. That would be easier than actually writing this 5 into 32 mux instantiation, which is around 162 mux definition, and into 2, right? 162 into 2, which is around 234 or so mux definition, and their connection, it will be a bit crazy to write that directly. Okay, you can choose that, of course. You can choose and write it very carefully, make the connection right, and so on and so forth. But I myself implemented it with a generate variable, little bit logic, a little bit tricky logic inside the generation technique, but ultimately it's a very compact writing, like probably 50 line of code. Okay, 50 line of code to write a generate statement for each of them. It should be less than 50. So try the generate variable technique to do this implementation on the barrel shifter 32-bit. So once you have that, then we connect the right shifter, left shifter, and select the result depending on whether I want a left shift or right shift. And once we have that, and remember, my barrel shifter is taking 32-bit and 5-bit, but in fact, my ALU, this shifter will go inside the ALU, and ALU takes both of the operand 32-bit. That means, let's say one of the operand will be 32-bit directly connected to the barrel shifter, and another 32-bit operand we take, I haven't shown it here, but we take 5 bit 0 to 4 bit connected to this 32-bit barrel shifter we just implemented, 5 of them, and rest of them 27 bit will be connected to a OR, 27-bit OR. So why so? So the logic is that we are trying to test if there is any bit on after the 5th bit in this number. Anything after the 5th bit means I am requesting a shift more than 32. And if it is shift more than 32, then my result will be 0 no matter what is this number is. Okay, so I take the 5-bit normal shift, that whatever 5-bit shift is saying that, but if any bit on beyond the 5th bit, which means I am asking for a more than 32-bit of shift, that will be reflected in this output. This is 1-bit output, 27-bit OR, which will OR all the bits, higher bits, and if anything is 1, this will be 1, and if it is 1, then I know my result is going to be at 32-bit 0. Okay, no matter what this number is. If it is, we are asking for more than 32-bit shift, result will be 0. So it will select that. Otherwise it will select, if it is less than 32 the shift amount, then it will go and select the correct result depending on this control, like left shift or right shift, and put the output right from this barrel shifter. So this becomes a top level barrel shifter which takes both of these numbers as 32-bit and a control, and we'll stick that in, plug that in an ALU. Okay, so we do the barrel shifter, and this rest of these things are much easier, like 32-bit, and I requested you guys to implement that upfront because you need this module for your multiplication. Remember, your multiplication is involved with the 32-bit AND operation, so you already have done this. Then NOR, which I have already done with the gen variable generate technique, generate block technique in the last lab. We have 32-bit inverter, like the similar thing. Make a OR. Okay, you can use that OR as an OR instantiation, or you can reuse my NOR and AND, connect them together to make a OR. It's your choice to what you want to do. So once you do that, I think at this point we are ready to implement a complete ALU, get level ALU. We'll do it in the next lab then. Okay.